Like we've been doing, I give you the solved equations. If you want to solve for heat, here's the equation. Heat will be measured in joules. If you want to solve for mass, it's heat divided by change in temperature and specific heat. Note, whenever you put something in the calculator, make sure the denominator is in parentheses, or use fraction form. To find the change in temperature, it's just heat divided by mass times Cp. This will either give you the change in temperature in degrees Celsius or Kelvin. Either one's fine. Specific heat is going to be measured in joules per kilogram degree Celsius. So let's work on some examples. Also remember, if you see it, we need our mass to be in kilograms. So if you're giving grams, you're going to have to convert it into kilograms. We also want our energy or heat to be in joules. So if we're giving kilojoules, we need to convert it into joules by multiplying by 1,000. Kilo means 1,000. So a kilojoule just means 1,000 joules. So 5 kilojoules of heat is added to water that is at 20 degrees Celsius, causing its temperature to rise to 50 degrees Celsius. How many kilograms of water is there? So we're solving for kilograms. We're solving for mass. We're given energy, but we're given energy in kilojoules. Our energy is going to be our heat. So this will be our heat, represented with a Q. So how do we convert kilojoules to joules? So what is 5 kilojoules in joules? I'll put y'all's mask on properly. For initial temperature, 20, and our final temperature, 50. Yes. For this equation, you can just leave everything in Celsius. So what is our change in temperature? So it would be this minus this. Final minus initial, so 50 minus 20, 30 degrees Celsius. So we're trying to solve for mass. Mass is equal to heat divided by change in temperature times Cp. Make sure you put the denominator in parentheses. What is Cp? Well, Cp depends on the type of substance. What substance are we dealing with? Water. Water specifically as a liquid. So on the back of your paper is a list of specific heats. We look up for liquid water, and we see it here. Water is liquid between 0 and 100 degrees, so we use this value right here, 4,186. We'll add that to our list of variables. Yes. Same way you heat up a liquid or a solid. So this is in joules per kilogram, Kelvin, or degrees Celsius. So this room, the air we're breathing in is a gas. How do we heat it up? Turn on the heater. And Michael, your mask. Yes. It can explode if you get enough pressure. Again, it's under high pressure in a gas canister. So now we have all of our information. We can plug this in. So heat is 5,000 joules. Our change in temperature is 30 degrees Celsius. Our specific heat for water is 4,186 joules per kilogram degrees Celsius. So joules cancel out, degrees Celsius and degrees Celsius, and we're left with kilograms. And so it's 0.03981 kilograms. Stop talking. If we wanted to convert this into grams, we can do the opposite. So this is grams to kilograms. We divide by 1,000. If we want to go in the opposite direction, we just do the opposite division. So we can multiply. You don't have to do your answers like in grams. You can keep it in kilograms. But we can multiply by 1,000, and that's 39.815 grams. But it asks for the answer in kilograms, so this would be the answer. Yes, but we usually pronounce it as kilometers. Oh! Yes. Yes. Kilometer is the only one where we actually change the pronunciation of the word after adding kilo to meter. So, kilometer. So we usually in English would pronounce it kilometer. Kilometer is a acceptable pronunciation. It's just very weird. So you're not fun. Everyone good? So I want you guys to try solving this on your own. Water is initially at 20 degrees Celsius. The mass of the water is 500 grams. And we add 10 kilojoules of heat. What would be the final temperature? That's the water. That's the mass of the water in your bottle of water. And then add it to your initial temperature. Just put the go over that. What would be the final temperature of the water? Recall that final temperature is equal to initial temperature plus whatever temperature you change. We're given initial temperature, so all you have to do is solve for final temperature, or change in temperature, and add it to initial. I would add that to your thing. I'd add this equation right here to the bottom of this somewhere. Yes. Initial temperature is equal to our final temperature is equal to initial temperature plus change in temperature. So the definition of change in temperature is TF minus TI. And all we did was add this to this to get the equation. So what you need to do is solve for delta T first and add it to your initial temperature to get final. KJ stands for kilojoule. Yeah. So try solving for it. What's going on? Does someone have your calculator? What number is your calculator? Does anyone have 17? So what'd y'all get? Anyone else get that? Alright, I'll stop. So this is our heat. This is our initial temperature. And this is our mass. So mass needs to be converted into kilograms. So 0.5 kilograms. Heat needs to be converted into joules. So 10,000 joules. Again, looking up on the table, CP has 4,186 joules per every kilogram degree Celsius. We're also given initial temperature is 20 degrees Celsius. So we need to solve for initial temperature first. Initial temperature is equal to heat divided by mass times Cp. So that would be 10,000 divided by 0.5 times 4,186. And we get that the temperature changed by 4.7778 degrees Celsius. This is positive. That means we added 4.7778 degrees Celsius. So we started out with 20 and our temperature changed by this much. So our final temperature be whatever we started with plus our change in temperature. So 20 degrees Celsius plus 4.7778 degrees Celsius. Our final temperature would be 24.7778 degrees Celsius. Everyone good? We have 1 kilogram of a strange material. We add 4,140 joules of heat to this material, causing its temperature to increase from 20 degrees Celsius to 50 degrees Celsius. What material is this? So how can we figure out what material this is? So we have a table of materials or substances, and they all have different specific heat values. So if we calculate the specific heat, we can figure out what the material is. So try solving this on your own. Thomas, your math. So we basically need to find specific heat or CP first. Where do you see gram anywhere in that problem? Can you put your mask on properly? It's already in kilograms. So we have 1 kilogram of a strange material. We add 4,140 joules of heat to this material, causing its temperature to increase from 20 degrees Celsius to 50 degrees Celsius. What material is this? Stop clicking. And put your mask on properly. Michael, put your mask on. You guys get an answer? What y'all get? So our initial temperature, 20 degrees Celsius. Our final temperature is 50 degrees Celsius. So our change in temperature would be final minus initial, so 30 degrees Celsius. This would be our heat energy. We can identify material by specific heat. So specific heat would be equal to Q divided by change in temperature and mass. Our mass, 1 kilogram. So that would be 4,140 divided by 1 times 30 degrees, 30, and you get 138. CP is measured in joules per kilogram degrees Celsius. So we're adding the units, we can see where it comes up with that. Joule, kilogram, degree Celsius. So this is our specific heat. Looking at the table, the only one that has a specific heat of 138 is mercury. This can be used to identify substances. You can figure out how much heat you're adding. It feels stuffy. Put your mask on. Alright, so a quarter of a kilogram of nickel loses 1,000 joules of heat. What would be the change in temperature? Note, heat is negative if released. You could also write loss, and positive if gained. So it loses 1,000 joules. So our heat is going to be negative 1,000 joules. So you have to actually read. If it says that the heat is lost or released or it loses, then you make heat negative. A quarter of a kilogram for some reason you guys seem to struggle whenever I write the number in words. How much? What would be the numeric value of a quarter of a kilogram? 0.25. Make sure you include the 0 before the decimal. And looking at the table, we can look up the CP value of nickel. Nickel has 440 joules per kilogram degree Celsius. And so the change in temperature is equal to Q divided by mass times Cp. So negative 1,000 divided by a mass of 0.25 times 440. And we get negative 9.0909 degrees Celsius. Note it's negative because it loses heat. It's going to get colder. So if it was initially at 30 degrees Celsius, then the final temperature would be what? So again, final temperature is equal to initial plus your change. So our initial temperature will be 30 degrees Celsius plus a negative 9.0909 degrees Celsius. And we get a value of 20.9091 degrees Celsius. So the final temperature would be this. Are y'all getting this? Seems pretty simple. And Michael, your mask. Isn't this almost 21? 20.9? Isn't that almost? This portion causes it to be a little less than 21. Well, this is almost negative 9.1. And if you start out with 30.0, well, this should get you a 9, which means you have to convert this into 29. 29 minus 9 is 20, so you get 20.9. I think so. So the code word of the day for remote learners. So tomorrow I'll give a little worksheet to do in class. What are you doing all day? You're trying to get out of it too? What was your fix? So again, you're trying to get out of it. How can you not see that? How can you not match?